Now, can you imagine if every building in Jamaica was employing this type of technology, energy efficient architecture, and renewable energy? It would mean that our demand for fossil fuel would reduce. Any contaminants, any pollutants to our environment would be reduced as well.
Welcome to the region's first net zero energy building, located at the University of the West Indies Mona campus. This beautiful, climate-smart, and state-of-the-art facility hosts the Center for Advanced Research in Renewable Energy. It is the result of efforts from the Institute of Sustainable Development at UWI in partnership with the Global Environment Facility and the United Nations Environment Programme. World energy demand is projected to grow by more than 50% by 2030, with 75% of that coming from developing countries. This is the result of several factors, including China and India's rapid growth, world population increase, and the unmet demand of 30% of the world's population without reliable energy supplies. Increased demand for energy services will make it very difficult to meet carbon reduction targets, resolve climate change problems, and meet national needs for energy security without significant improvements in energy efficiency and productivity. It is important to improve the energy performance of buildings, as the residential sector alone accounts for 25% of total end-use demand and 19% of global GHG emissions. That means even basic improvements in building efficiency would reduce world end-use demand for energy by 30 quadrillion BTU. The Institute of Sustainable Development at the University of the West Indies pioneered a project to develop innovative solutions for Jamaica and the Caribbean.
And adaptation now requires us to think, well, how do we get efficient cooling? Because we're going into a warmer world. How do we use, for example, more efficient usage of water? How do we use shades? And so the whole building and construction industry also has to look at adaptation as a key part of living in this world as we go forward. And hence the whole idea of efficient buildings playing a role both in mitigation and in adaptation.
Its first phase was to show what could be achieved with new buildings. This involved constructing a net zero Energy Plus Energy building, NZEB, on the Mona campus. Let's get a panoramic view of the site while we discuss net zero energy. This building has two main features. The first is its high energy efficiency. To get to that, we changed the orientation to the sun and reorganized its internal layout to keep the living area cool. Those changes reduced the energy needed to keep the building well lit and comfortable. The second feature is its use of renewable energy, in this case, solar power, to meet the building's residual energy demand. Because the building is so energy efficient, it will actually export power much of the time.
A lot of work have been put into making this building possible, and it would be a waste if it didn't get itself into the building code. Just in terms of the orientation of the building, measuring the way in where the sun comes from and so on, to minimize the heat.
Let us go into more detail. We chose the orientation of the building to minimize heat gain from the sun, make use of natural breeze, and maximize renewable energy production. You can see the way that the building has been oriented to take account of the sun. Also, look at how shading has been used on the south side to help keep the building cool. The building was designed to let in light rather than heat, so there is little need to switch the lights on. Now, what really is a net zero building? Or an Energy Plus building? A net zero building is a building whose total amount of energy used roughly equals the renewable energy created on the site or at other renewable energy sources. For example, our building generates enough energy on site from renewable sources to meet its own needs. As a result, net zero buildings do not increase the amount of greenhouse gases in the atmosphere. Did you know buildings account for nearly 40% of total world resource demand and 1/3 of global greenhouse gas emissions? If all future buildings were built like this, we could solve climate change. It does not stop there. This building was also designed to reduce water consumption. Half of humanity now lives in water-stressed areas, so this could be a very important feature in new building design from now on. As you can see here, the building collects rainwater that is stored and used to flush toilets and urinals. The toilets use 50% less water than usual to make sure that the building does not run out of water. We could also use the stored rainwater to put out a fire, adding a safety feature for the building's occupants. So this simple design feature serves many valuable purposes. This building is a showcase for current best practices in the built environment and is an example of what offices and housing will look like in the future. Let's go inside to take a better look at these best practices. Best practices in this building include an energy-efficient layout, window detailing, and efficient lighting and cooling. The use of PV solar panels on the building can also provide energy to the grid when the building generates more than it needs. The building design even makes it resilient to changing climate conditions, storms, floods, and earthquakes. Raised flooring means it is above floodwater levels, while the robust structural engineering makes it resistant to strong tremors. At 2,400 square feet, the building was built specifically to produce enough or surplus energy for its needs. Please note that this is larger than the average house size in Jamaica, so you could easily be living in a building designed like this in future. This project is more than a building. It was designed to provide practical solutions. Buildings like this show how Jamaica could improve energy efficiency, make everyone better off by increasing disposable income, stimulate the economy, reduce Jamaica's fuel import bill, soften our exposure to energy price volatility, and reduce the national contribution to climate change. What is not to like?
One of the things that we want to do is ensure that every new building in Jamaica from now on is built to somewhere closer to net zero standard. And we now know how to put up buildings that actually generate as much power as they consume, which means that those buildings are actually not generating any net demand on the grid at all.
Even if we could make every new building like this, it will take many years, perhaps decades, to change the entire building stock. That raises an important question. How can we continue to make progress in that time? This project was designed to answer that question too. Its second phase was to show how much we could gain from retrofitting existing buildings. So we upgraded a large, busy building, the National Housing Trust headquarters, to modern standards of energy efficiency. We reduced heat by improving window films that allow more light in, but reflects unwanted heat back out. We insulated the roof, which can reduce heat by as much as 80%. To reduce electrical consumption, we upgraded lighting fixtures from fluorescent to LED, which give more light for less power. We also installed occupancy sensors that turn the lights off automatically when no one is in the room. We upgraded the old air conditioning and cooling system to modern standards that will save a lot of power. The solution to many of the world's most pressing problems, the need to support more people at a higher standard of living while also solving climate change, lies in building better, smarter buildings. This pioneering world-class project shows how that can be done. This building is a symbol of Jamaica's commitment to tackling the world's great environmental challenges. It is the first of its kind in Jamaica and the Caribbean. But the people who designed and delivered this project want to share the lessons learned so we can see more buildings like this in future. The project's two principal investigators are Professors Anthony Clayton and the late Tara Dasgupta. The project manager is Kevin Rodriguez, and the project administrator is Engelbert Davis. We are always willing to share what we know with audiences and partners across the region and beyond. This is a site for learning and creating. We would like to thank the stakeholders, contributors, and co-financiers of the project, who include the University of the West Indies, the University of Technology, the Scientific Research Council of Jamaica, Jamaica Public Service Company, Jamaica Institution of Engineers, Jamaican Institute of Architects, Office of Disaster Preparedness and Emergency Management, Caribbean Academy of Sciences Jamaica, the architects and engineers who worked on the project, the CARICOM Energy Secretariat, and the GIZ. Feel free to use this facility as a site for knowledge transfer by contacting us today. And please be sure to come and visit and get a glimpse into the future.